we have to simplify the radical. And for us to do that, I'm going to give you all a trick. There's a miserable way by multiplying everything by radical 14 on the top and the bottom. Imagine multiplying 14 with 126. That is not pretty. And I want you guys to do this without a calculator. So here's what you can do. As long as you have the same radical, the numbers in the inside could be divided as long as it works out. So in this case, can 14 go into 126? Think about 140. 14 can go into 140 how many times? 10. So clearly 126 is one set less than, so it'll be 9. So 2 radical 9. And then you'll look and say, well, we can further split this guy right here. Isn't that a perfect square? Yeah. How many? 3. So 2 times 3 is 6. So you could take it in a miserable way and multiply by radical 14 on the top and the bottom, get a big number, simplify as you go, and we'll get the exact same answer. All right? So let's go on to number 9. On number 9 says the conjugate. And conjugate simply means if I see a minus, we put a plus. If I see a plus, we put a minus. So in this case, we're going to actually look at the conjugate of, so isn't 7 a normal number basically? Yeah. Any whole number is normal. Whichever one is not the norm is the one that we're going to make opposite. So it'll be 7 plus 8i, and that is it. So conjugate is the opposite sign of the one that's not a norm or normal number. So what can we say about this one right here?
9 plus.
9 plus a radical 7?
Number 7 would be negative 3 root 5.
Uh-huh.
Minus 4.
Now some people might argue and say 3 radical 5 plus 4. That's also going to work. All right? Just heads up on that. Okay, I'm going to move on. Let's go to number 10. Okay, on number 10. So it says simplify using the conjugate. So looking at my denominator, I need to go ahead and put this in parentheses since I'm thinking ahead. The conjugate of that denominator is 3 plus radical 3. And we do the same thing on the top and the bottom. Because if I don't do the same thing on the top and the bottom, the number is not going to be preserved anymore. So let's do our distribution. So we're going to take the 2 and multiply. So 2 times 3 is 6. And then we have that understood 1 in front, so we have 2 radical 3. And since we did factoring last time, isn't this difference of 2 squares? Yes. So if that is difference of 2 squared, it's basically 3 squared, which is 9, minus, what is the square of the radical 3?
3.
Just 3. And let's further simplify. 6 plus 2 root 3. And 9 minus 3 is how many? 6. And looking at the whole numbers, are they all commonly divisible by something? What is it? By 2. So I could say my final answer, or the best answer, is 3 plus the radical 3 over 3. All right? So let's go on to the back. So we said something in the 20s. Bless you. On 23, if I have 2 different factors side by side, what operation is understood there? Multiplication. So when I multiply 2 times 3, I get 6. 2 times 4i is plus 8i. And then on the second one, 3i times 3 is plus 9i. And then I have 3i times 4i is how many? Oh no, my 12 looks like it's on top of the plus sign. 12i squared. Let me make it neater.
Is I squared 1?
What was it? Plus what?
12i squared.
12i squared. Okay, let's do a recall on, it's almost. On our i's. I stands for radical negative 1. Then I squared must be negative 1. What about I cubed? Negative I. What about I to the power of 4? If I have 2 of these, positive 1. So given that, let's go ahead and see what I can. Go ahead and resimplify. This alone is going to be negative 1. So when I combine like terms, it's really 6 minus 12, right? So that's going to give us negative 6. How many i's do I have? 17i. And we want it in terms of one single I. I see one single I. Okay? So we're good to go.
Wait,
What's up?
wait, so I cubed is negative I?
Mm-hmm.
How?
How? So the way I see I cubed is the following. I see it as I times I squared. What is I squared? So therefore, negative 1 times I is negative I. Okay? All right, let's go on to number 25. We need to multiply by the conjugate of the denominator. So let's go ahead and put that in parentheses. What is the conjugate of this? Look at the bottom. 2 plus 5i. 2 plus 5i. And let's go ahead and double distribute on the top. We have 3 times 2 is 6. 3 times 5i is how many? 15i. And then 4i times 2 is how many? 8i. And then 4i times 5i is 20 what? I squared. Now just circle this as a reminder. That's going to be a negative 1 at some point. Let's do difference of 2 squared on the bottom. If I take 2 squared is how many? 4 minus 5i all squared is 5i squared. Again, I see a negative 1 right here. That's a negative 1. That is a negative 1 as well. So when I combine like terms, I'm really doing 6 minus 20. How many is that? Negative 14. And then 15 plus, or 15i and 8i is how many?
Wouldn't it be 25i squared?
Is it 25?
It's 5i, all of 5i squared.
Oh no, look what I do. That's a sad day.
That's a point.
That's a point. Good point. All right. So we have, okay, how many was the i's when I combine on the top?
23.
Plus 23i. And then we know because that's negative 1 times a negative 25, our whole number really in the end is what? 29. And look at the numbers and see if it's divisible. 14, 23, and 29. We have no common value.